which 112 is all about transformations, different kinds of transformations. So let's do example 9, and then there's a good summary activity on the very last page of the 112 notes. But let's do example 9. We haven't done that one yet. So we've got a function p. And we're going to build a new function called r that is the image of the graph p after a horizontal translation of 4. So a horizontal translation of positive 4. All right, so what will we have to do to this to accomplish that? A horizontal translation of positive 4. What does that mean? That means we're going to move 4 to the right. So what would I have to look like?
Multiply 3 by x minus 4.
This would be x minus 4. Would that move us 4 units to the right? It sure would. So our new transfer, or our new function then would be this. Would you agree with that? And that's all there is. That was example 9. We did the first 8 and didn't do number 9. So there it is. So A is still 3, but now B is negative 14. Because shifting your line to the right will change its y-intercept, obviously, right? So that's it. All right, perfect. Now, we did the next couple pages. Go to the back of the page that says, what's my transformation? Go to the back of that page. So it's the very last page before the new note, the 113 notes. So at the top it says transformations of functions and has a little table there. All right. So this is our review. This is our summary of this. So here we go. If we want to accomplish a vertical shift, what notation? Like f of x, what happens to f of x if we are going to do a vertical shift? What do we do to that? How do you do a vertical shift? How do you move things up and down? Add or subtract. So I'm just going to say plus. They don't really tell me what letter you, oh, I'll use the same letters they use. When he writes his functions, he uses these letters. That kind of stuff. So I'll use D. That's what accomplishes a vertical shift, right? Doing a plus something. And if that number is positive, then what happens? It goes up, yeah. And if it's negative, we go down. Okay, so characteristics, it moves up when that's a positive number, and it moves down when that's a negative number. Now, how do we do a horizontal shift? Charlie?
Add or subtract the index.
Yep. Like this. Now, moves right when what? When does that move to the right? When C is negative? Because that would make it minus C, and that's how I go to the right. And then if C is positive, we will go to the left. How do we do a vertical dilation? A dilation, remember, is just a stretch or shrink. How do we accomplish that? So we'll put a number out in front like that. And what are the characteristics? That, well, the dilation factor is A. So the factor is A. And then it stretches in the y direction, so it stretches vertically if what? A is bigger than 1. Beautiful. And it shrinks in the y direction if A is less than 1. And then how do we do a horizontal dilation? Multiply the x. Now be careful, what is your dilation factor here? It isn't B, it's actually 1 over B. Remember, this guy's a divider. Okay, I know this isn't nearly as fun as guys on bikes, but are you guys awake? Or alive and breathing? Okay. That's your dilation factor. All right. Now, it shrinks. When does it shrink?
B is greater than 1.
If B is greater than 1. When does it stretch? And I gotta be careful here. I did the same thing over here. I am gonna do this. Because if I just say less than 1, that could be like -5, and that would not be what I mean at all. So I'm gonna say some kind of fraction between 0 and 1. Now, if I wanna do reflections, then I will have negative numbers, right? Put negatives in. So how do I accomplish a reflection over the x-axis? What does that look like? Over the x-axis would look like negative f of x. And then over the y-axis would be f of negative x. So that chart right there just kind of summarizes everything that you can do to your functions. All right, so with that in mind, would you and your partner work on, check your understanding, list the parent function, list that library of functions that we had the other day, list the one that corresponds to each of those, and then which transformations have happened. So go ahead, work on 1, 2, 3, and 4. I take 10 minutes. What did you think about, which parent function is a, 1A? Quadratic. And what have we done to it? We've moved it down 3 and stretched it by a factor of 2. What about B? B is obviously absolute value, and it has gone right 4. And what about C? Definitely a cubing function, absolutely, that has been reflected across the x-axis, so it's upside down. And what else has happened to it? What do you think? It's been vertically stretched, not by a factor of 4, but actually by a factor of 64. Would you agree with that? All right, what about your equation for number 2? What does that look like? Y equals what? Square root of x plus 7 and plus 2 on the outside. Yep, very, very good. Very good. Number 3, did you figure out which of those equations matches the curve?
D.
D? Well, let's check that out. Let's check that out. So here's the equation. All right, so let's put in, I don't know, let's put in 0 for x. Okay, what happens if I put in 0 for x? What does that equal? If I put in 0 for x, that's going to equal 9. Is the y-intercept of my picture 0, 9? No, so it probably isn't that one. Anybody have another guess?
C.
Which one?
C.
C? All right, let's try C. First of all, the vertex of this guy should be at 3, negative 4. Is the vertex of my picture at 3, negative 4? Okay, that's good. Where's the y-intercept of this equation?
It's a fraction between 0.
The y-intercept would be 0.5. Does that look like that's a possibility on my picture? Yeah, so I think C is the right one. And finally, what about number 4? What did you think about here? Which of the following would give the allowance amount of a kid who is 3 years younger? Which one did you guess?
Also C.
You said what?
Also C.
C, you're right. I think it's C. Anybody who have a question about that or want to argue with that? Remember, the input value is the age. So we have to input 3 years younger than the kid is already. So T minus 3, very, very good. Good, good, good. Okay. There was in our homework, I'm not going to do all of it, but there's one I want to do, one section I want to do real quick. So if you can get out your 1.12 homework, which I'm assigning today, so it's due on Tuesday. In the 1.12 homework, let's look at number 2. Problem number 2. Alright, so this is another one of these where we have a table of values, but the table is function g. And then the question, make sure I copied this right. The question number 2 involves function n. Okay, so it says n is this new function, which is a variation of function g. So we did some of these yesterday or some other day. Find n of 3. What did we decide we were going to do? We did several of these. What do we do? Charlie?
Find 3 on 3.
Well, we plug 3 into our function.
Right.
We're finding n of 3. So wouldn't n of 3 be 2 plus g of 3 over 3? So I don't look for 3 in the table, I actually look for 1 in the table. And g of 1 is 6. So the answer would be, the answer to this problem would be 8. Right? Okay, how about B? Do B right now, see if you can get B figured out. You're doing the same thing. You're putting negative 3 in there now. Anybody have an answer yet? Leo? 4. Leo got 4. What did you get? 4? Everybody okay with 4? All right, let's look at C. Now C is a little different. Because C doesn't say find n of 4. C says find an inverse of 4. All right, let's hear some ideas. Charlie,
We could plug 4 into the original equation.
plug 4, like into here?
Yes.
Okay. All
Oh
right.
wait, never mind. I'm sorry. So since it's the inverse, you'd actually switch the x to the g of x. So it would actually be negative
So
1.
let's talk about that for a minute. Charlie says n inverse of 4 equals something, right? I'll call it A, right? The something. That means that n of that something has to equal 4. Remember the inverse relationship, the relationship between inverses? They are x and y get switched. So if the original ordered pair is a comma 4, the inverse ordered pair will be 4 comma a. So n of a is 4. Well, wait, isn't n of a 2 plus g of a over 3? I'm finding n of a, so 2 plus g of a over 3, and that has to equal 4, which means that g of a over 3 has to equal 2, if I just solve this. G of what equals 2? Let's look in the table. G of what equals 2? So, since g of negative 1 equals 2, doesn't that mean that a of a over 3 has to be negative 1? So the answer to the question, the a that we were looking for, is negative 3. So Charlie was exactly right. He said because it's an inverse, we have to think about it backwards. Not looking for a y, looking for an x. Okay, so we'll talk through that one more time. This is our function right here. This is our function. And we are told and asked to find n inverse of 4. And what does that equal? So I called it A, you could call it something else. I called it A. If the inverse of 4 is A, then the original of A is 4. These ordered pairs are switches of each other. N of A, this guy right here, has to equal that number. So that's N of A. Move the 2 over, and then use the table backwards. Okay? I can't remember if there's any more like that, but we'll have another one on some review sheet somewhere, I'm sure. All right, good deal. Got homework, work on that. I'm going to try to put together a little transformation practice sheet too, maybe for next time. But right now we're going to go to our calculators. And some of this you already know, so I don't want to bore you even more than you're already bored. So let's go to example 1. We're going to skip all that reading stuff because I think you already know how to do it, but if you don't, we'll take the time to figure it out. Let's go to example 1 and see if we remember how to do this. The age in weeks and the weight in kilograms of babies are listed in the table. Everybody on example 1?
I'm confused on this one, like what you're gonna look at when you have the G of A and
It says G of something is 2. G of what gives me 2?
Okay.
So whatever that is, it has to be -1 because that's the only way I get 2. All right. So let's put the data in. Does everybody remember how to put the data in to your calculator? So let's do that. Everybody remembers, right? Then get up here. If you don't remember, get up here, bring your calculator. Everybody else, let's get it in. So we have the stat, edit. And then I got stuff in there, so I'm gonna go up to that, here, enter, and clear those out. So I'll go up, highlight this heading, clear, and enter. And then I put in data. So right now, we're just getting it all in our calculator. So you should have your L1 and L2 columns filled in. Got it? Yep. Okay. Now, he suggests that we do a linear regression of this, and he wants us to use the form. I don't think it matters, like, in terms of the exam or anything, I don't think it matters at all. But he wants us to use that linear regression. So we'll go back to stat, over to calc, and then go down, let's see, for me, it's number 8. There are 2 linear regressions. And apparently in AP Stats, you use this one for some reason, but I don't know enough about it to know why. It doesn't matter, I don't think. But we'll use this one because that's what he said to use. Okay? And then you're just gonna press enter. Now, this is where things get different depending on which calculator you have. If you have one of the newer ones, it comes up with a whole list. It says X list, Y list, frequency list, store regression, and calculate, right? It says all those things. We want to actually store a regression equation. So we're going to store Y1. Now, how I get Y1 on my calculator is I go to vars, variables, it's next to my clear button, and then over to Y vars, so click over to Y vars, and then right there, Y1 is the first entry, hit Y1. So, the function, yeah, and Y1. There you go, so it's stored Y1. And then go down to calculate. Okay, and it has calculated now. I have to do mine now. If you, everybody get an equation? Or if you have an old calculator, you might want to come up here and I can show you how to do it on the old calculator. Because we need to store that equation. We need to store it. And then it should give you the equation. Did you get y equals 3.545 plus 0.185x? All right, who did not get that? No matter what kind of calculator you have, you should have gotten that. Okay, all right, good. So there it is. There's your regression model. So underneath all those pictures, it says, what is your linear regression model? Right there it is. The model is called that's what he calls the equation you come up with on your calculator. All right? Now, using this model, what is the predicted weight of a baby that is 10 weeks old? So one option you would have would be to put 10 in right here and work it out. But that will often involve round off, not in this particular case, but often. So I'm going to show you something else. The preferred way of plugging in a number, whatever it is, the preferred way of doing that is to go back to your vars, the variable button, go over to Y vars, function, Y1, and then in parentheses, put the number that you would have plugged in. So 10, and then it says 5.395. Now the value in doing that is, usually when you do a regression equation, it has a ton of decimal places. And so when you go to use that equation to plug a number in, you have round off or a ton of time involved in typing all those digits. So if you want to plug a number into your equation, let's do another one. Let's see, for a 13-week-old baby. So for a 13-week-old baby, we go to vars, Y vars, function, Y1, and then put in our 13 in parentheses. And that would be 5.95. All right? You always have the option, once you have built your equation, you always have the option of plugging your number in. But again, remember in our curriculum we round to the 1,000th, and so round off error can compound, and you might be off a little bit if you're using rounded off data, okay? If you did not store your equation, you can't do this. That's why I want you to get in the habit of storing your equation. So when you press second calc, press stat calc, pick your regression, store that equation. And if you have an older calculator, it doesn't ask you to store, like mine doesn't. So that I will help you. I will show you how to do it on your calculator. But you need to get that equation stored. And then it's in there. So right now, press Y equals, guys. Press Y equals. See it sitting right there? So if you wanted to graph it now, you could graph it. You could do all kinds of things with it. It is going to stay there until you take it out. All right. Now C. The weight of another baby is 5.3 kilograms. Using the model from part A, which is right here, this is our model. Oh, you're kidding me. Okay, all right. Well, I'm not going to see you on Monday to remind you. So remember, Math League is Tuesday, and